This conference will now be recorded. This conference will now be recorded.
Okay. Good morning, good evening, and good afternoon, folks. Welcome to today's SONiC community meeting. So Microsoft team will present the portable console switch HLD. Let me hand over this to Zhijian. Okay, please go ahead.
Yeah, hi. Good morning, good evening. Can you hear me?
Yeah, I can hear you.
Okay, I'm sharing my screen now. Thank you for joining this community review today. This is Zhijian from Microsoft SONiC team. I'm very pleasant to give you this presentation about the portable console device design. Please feel free to interrupt me if you have any questions during this meeting. Okay, let's start. So considering someone may not familiar with a console device, let me first spend about 2 minutes to introduce it first. Here is a picture from our SONiC repo. And in this picture, you can see a console device is a hardware which contains many console parts. And it usually also contains at least one USB port. The console device can be connected to a switch by using a USB link. Then this switch will gain some console parts, and we will call this a console switch. And if on this switch the operation system is SONiC, then we will call it a SONiC console switch. After plug in the console device, the switch can manage network devices not only through the Ethernet ports, but also through the console ports. And if we want to manage a network device from the console ports, we have to connect these console ports by using a serial link. So this is an introduction about what is a console device and how it works. Okay, so let's go back to our portable console device design doc. So in this design document, we provide the standard for adapting the console device to SONiC. If a vendor's console device implements this standard, it will work on any switch with SONiC design, which SONiC installed. And this is why we call it portable. In this design doc, it mainly contains 4 sections. The first section contains some assumptions on the portable console device. And the second section, we will describe how to set up a portable console device in SONiC. This is mainly about how to make the console device work correctly after it is plugged into a SONiC switch. And in the third section, we will design the portable console device API. Here are some Python APIs, and used after the vendor implements this Python API, users can interact with the portable console device by writing Python codes. And the first user of the Python API will be our SONiC command line. And in the last section, we will contain the SONiC command line design. In this part, we design how the SONiC command line interact with the portable console device. So let's go back to the first section.
Hi,
Here we
this is hello.
Yeah.
This is going from Art. So, is this a console device is an external entity or is it part of SONiC? Is it a physical separate device?
It's mainly designed about the API for SONiC to interact with the console device.
Yeah, is it a physically a different device? This console device, is it a separate device?
It's
Yeah, it is a pluggable device. Actually, the console device, just like your keyboards or like your mouse, is plugged with your switch and extends the functionality to manage other device via console. So basically, the console device is a headless device, but once it connects with SONiC, SONiC can manage it. So it is a separate device.
Yeah, in this picture, you can see it is plugged into the switch by using a USB link here. Okay, so we have three assumptions in this design doc. The first one is we only support USB console devices, which means you can only connect the portable console device to SONiC switch by USB link. Maybe in the future, we will support more type of interface like PCIe, but in current design, we only support USB. The second assumption is only one model of console devices can work on SONiC switch at the same time. If console devices of different models are plugged in at the same time and users don't manually specify the vendor name and model name, then none of these devices will work. I will explain more about this in our third section when we design the factory function. And the third assumption is multiple console devices of the same model from the same vendor can be daisy chained to extend more console ports. Whether daisy chain is supported and how many devices are supported in daisy chain depends on vendor's implementation. Okay, so in the second part, we will describe how to set up a portable console device in SONiC. So after the console device is plugged into the SONiC switch, we need to set up the console device in SONiC for further use. The setup process maybe includes installing corresponding drivers and map the console interface from dev/ttybusb ID to dev/console line number. And this is usually done with the help of udev. And maybe different vendor have some different other necessary steps for set up their console device. And in this design, vendors should package all the files and the setup procedures into a corresponding Debian package. The file name of this Debian package should be vendor name-model name.deb. Since we prefer the setup process can be completed after building a SONiC image, the files used to build a Debian package should be put in our SONiC build image repo. Then these Debian packages will be built and installed automatically. Here we have a diagram to illustrate that the building Debian package is one step of building SONiC image. While we are building a SONiC image, we will iterate and build all Wonder's Debian packages. And after these packages are built and installed in the image, we will think the portable console devices are set up complete. For example, vendors can prepare UDEV rules files in the Debian package and copy it to the etc-udev/rules.d during the installation phase. And in the post-installation phase, vendors can use this udev admin command line tool to trigger the udev rules and make it work. If the vendor decides to use udev rule, we have some conventions. As the udev manual page mentions, all rules files are collectively sorted and processed in lexical order. The name of the udev rule usually starts with a number between 01 and 99. This number specifies the priority of the udev rules. The larger the number, the higher the priority. So if there is no special needs, please set the priority of the udev rule file to 50. Then the file name should be look like 50-vendorname-modelname.rules. Okay, that's all about set up the portable console device in SONiC. Before we go to the third section about the API design, we need to describe what we changed in the config.db. So we have a console switch table in the config.db. It holds all the configurations about the SONiC switch features. In this table, we added 3 new fields. The key of this new feature is console switch column console management. And the 3 new fields is listed here. The first one is auto detect. Auto detect can be set to enable or disable. If it is set to enable, it means our factory function will auto detect which vendor's device is plugged in. And if it is set to disable, our factory function will read vendor name and the model name from config.db. The second field is vendor name. Its value should be a string. And this field means the vendor name of the portable console device. If auto detect is set to enable, then vendor name must be empty in order not to make it looks confused. And the model name is also a string. It means the model name of a portable console device. Unlike the previous one, if the auto detect is set to enable, the model name must also be empty. Then let's go through this API design. So first, let's describe about our code directory structure. So all the portable console device API codes should be put in our SONiC platform common repo. And we will create a directory named the SONiC console in it. This directory structure will look like this. Our base class is named the portable console device base. It will be put in the console base.py. And we will also have a class named the console line info. This class is used in the base class, and it contains the console line info in it, and it will be put in this line info.py. The factory function for creating the concrete portable console device object will be put in this factory.py. And classes implemented by vendors should be put in the corresponding vendor name directories. Different implementations of different models from the same vendor should be put in the corresponding console underscore model name.py. For example, we will implement a Microsoft simulator in the future, and we will put it in the Microsoft directory, and the file name will be console underscore simulator.py. The next part is console line info class design. In this class, currently we mainly have two information of a console line. The first one is the device index. The device index is the index of console device where the console line is located. It is a zero-based integer. Because vendors may support daisy chain in their console device, so here we need this device index to identify where this console line is located. And the second property is virtual device path. This should be a string. And this is the virtual device path of the console line. The virtual device path will be look like this dev console line number. This is the virtual console line. And then let's go through the base class design. So here I will open a new window. Yeah, on the right. In this design doc, I also provide some sample code about how to implement this base class, and I put it here. It's also in this design doc, but maybe later at here. We can review the base class design and this example codes together, because this sample code can help you to understand this base class design. In the base class design, some methods are marked as class method because we hope these methods can be called without an object is created. We have 4 class methods. The first one is plugged in. This method is very important. It is used to retrieve whether a portable console device is plugged in or not. This method is mandatory for factory function to auto-detect the vendor name and model name. In our sample code, actually, we haven't fully designed this method, and we will implement later. But what we want from this method is that if the SONiC simulate, if the Microsoft simulator is plugged in, then it should return true. If it is not plugged in, it should return false. And vendors should have their specific method to detect if their console device is plugged in or not. The second method is get vendor name. This method is used to retrieve the vendor name of the base of the subclass. And this method is mandatory for factory function to create instance from manual configuration. Here, the manual configuration means you can configure it from the config.db, or you can pass it directly to the factory function through a parameter. And the third method is getModel_name. It looks similar like the previous one. It retrieves the model name of the subclass. And let's take a look at the sample code. It's here. The get vendor name here is simply return the Microsoft, and the get model name return the model is simulator. The last class method is get instance. This method is used to build and return a portable console device object. This method has two return values, so it returns a tuple. The first value is an object derived from this base class. If the object cannot be created, you should return none. For example, if the device is not plugged in. The second value is a string. If the object cannot be created, then please return the error message in this value. Otherwise, return a simple string, an empty string. Let's take a look at the sample code here. The get instance will try to create a Microsoft simulator object. And if it creates it successfully, it will return this object and an empty string. And if it throws some exceptions when creating an object, then we will return none and return the error message. This will be helpful for debugging. And the following methods are not class method, and they should be called after an object is created. The first one is getNumberDevices. This method is used to retrieve the number of portable console devices plugged in. Maybe multiple console devices are plugged in by daisy chain, so we need to get the number. It should return an integer, means the number of how many devices is plugged in. The next one is get serial numbers. It is used to retrieve the serial numbers of these portable console devices. This method will return a dict. The key of the dict is the index of the portable console device. So as we mentioned before, this should be a zero-based integer. And the value of this dict should be a string, which means the serial number. As you can see in the right, our sample code, we define the simulator structure in the construction method. And here we have two devices. And on each devices, we have one console line. So here, the getNumberDevices will return the length of this dict, and it will return 2, means we have 2 devices, they are daisy chain. And the getSerialNumber method will return a deep copy of this serial number dict. It will return a dict. The key is the index, and the value is the serial number. Okay, the next method is getNumberLines. It will retrieve the number of console lines on the portable console devices. This is all the portable console devices. So maybe you have 2 devices connected to the switch and have 20 console ports on each device, then it will return 2 multiply 20 equals 40. And the next method is get all lines. This method will return the information of all the console lines on the portable console devices. It will return a dict. The key of this dict is the console line number. Console line number should be an integer, and it should be the same as the portable console device designed. This means if the console ports, physical console ports on the console device starts from 1, then this integer should be 1 based. If the physical port starts from 0, then this should be 0 based. It should be the same as the physical device designed. And the value is a object derived from our console line info. As an example here, the dict will look like this. The first console line return line number as 1, and the line info is this class. It is an object of this class. It has the device index as 0, means this line located on the 0 device, and the virtual device path should be dev console 1. The next method is getLine. This method takes an integer as its method, which means the console line number, and it returns the information of this specific console line on the portable console devices. As you can see in our sample code, this getLine method will retrieve the console information from this dict and return a deep copy of it. And if this line number is not valid, it will return none. Here is all the line info defined. Okay, so the next method is about PSU. The first one is get number PSUs. This method will return the number of PSU available on a specific portable console device. This method will take a device index as its parameter. It is the index of the portable console device. It's 0 based, and it will return an integer, means the number of PSU available on the specific portable console device. The second method is get all PSUs. This method will return all the PSU available on the portable console devices. It will return a dict. The key of the dict is the index of portable console device. It's 0 based integer. And the value of this dict should be a list. The objects in the list is derived from this class. The definition, this class is also defined in the SONiC platform common repo. You can find the code here. And this object represents the PSU available on the portable console device. Here is an example. So as the example shows, we have 2 PSU available on the first console device, and we also have another 2 PSU available on the second console device. The last method is getPSU. It takes 2 parameters. The first one is device index, and the second one is PSU index. Here the PSU index is the index of the PSU on a specific portable console device. For example, if you want to get this PSU1 on the second console device, then you should provide 1 as the device index and provide 1 as the PSU index. Then it will return this object. And here is our sample code. We hope vendors can implement this base class and implement all the interface methods. If some methods cannot be supported, vendors should raise a type error exception, as the Python documentation recommends the type error should be raised when the attempted operation on an object is not supported. So we suggest the vendor raise a type error exception for the methods cannot be supported. Okay, so this part is the sample code here. On the right, we have reviewed it, so we can go ahead. The last part of API design is our factory function. The name of our factory function is get portable console device. It supports 3 ways to identify which subclass should be used to create a portable console device object. Here we also have a diagram to illustrate what happens in factory function. So first, the factory function will read vendor name and the model name from the parameters. If both vendor name and model name are set in the parameter, then it will directly use this vendor name and model name to find which subclass should be used, and then call its getInstance method to create an object. This way is mainly designed to be used for writing unit test. Then you can simply provide which vendor name and model name you want to test in the parameter, instead of you configure them in the config.db. If these methods are not provided, then this factory function will check the config.db, and it will first check the auto-detect. If auto-detect is disabled, then the factory function will read the vendor name and model name from config.db and use this configuration to decide which subclass should be used and call its getInstance method. If the auto-detect is set to enabled, then the factory function will iterate all the derived subclasses and use its plugged-in method to detect the vendor name and model name. And it will return a list. The list contains all the devices plugged in. So if the length of this list is 0, it means no console device is plugged in. So we should return a none and an error message. And if if 2 or more devices are detected plugged to the switch, here the 2 or more means 2 different models are from to different model. It may from the same vendor or from different vendor, but at least they are different model. So here it will make our factory function confuse which object should be created. So it will also return none and error message. This is why we, in the assumption, we cite only one model from one vendor can be used at the same time. And if the length of this list is exactly 1, then we will use the auto-detect vendor name and model name to call the getInstance method from the subclass and create the object. And if the create process succeeds, then it will return the portable console device object. If it create failed, then it will return none and some error message. As we mentioned here, the auto-detect method is what we recommended. But we also provide 2 other ways to detect to configure which vendor name and model name should be used. These 2 ways are mainly reserved for more flexibility, so they are given higher priorities. For example, this can be used to write unit tests, and this way can be used when vendor cannot support its plugin method. Then if we manually configure the vendor name and the model name in the config.db, we can also make the device work correctly. Okay, so that's all about the Python portable console device API design. And the last section is SONiC's command line design. In the command line design, we mainly contain 2 parts. The first part is the show command. In the show command, the first command is show console summary. Show console summary will return the summary of the portable console devices. Here is an example. This show console summary returns the vendor name, model name, serial numbers, and if auto detect is enabled or disabled. The second command is show console vendor name. It will return which vendor name is using. Here, if auto detect is disabled, it will read the vendor name from config.db. Otherwise, it will read the vendor name from getVendorName method. It is the same behavior as our Python API design. The third command line is show console model name. This command will display the model name of the portable console device. And its behavior is also looks like the previous command. The next one is show console serial number. It will return the serial number of portable console devices. As the example shows, it will return 2 columns. The first column is device index, and the second column is serial number. The next command is show console virtual device list. This command will display the virtual device list of the portable console device. As the example shows, it will return 3 columns. The first column is the line number. The second column is where is this line located on? Is device 0 or device 1? And the third column is virtual device path. Our last show command is show command PSU status. This command will display the status of the PSU on the portable console devices. Here's the example. It shows what we will return. For example, we will return the console device and the PSU ID and the PSU model, PSU serial number, and some more information we can get from PSU. And the next part is configuration commands. Here we only have one config command, is config console auto detect. This command is used to configure auto detect. If auto detect is enabled, then you simply write config console auto detect enable. But if you want to set auto detect to disabled, you must also provide the vendor name and the model name. By default, auto detect is enabled, which means if you don't use this command to do any config, then auto detect is enabled. Okay, that's all in this design doc. Any questions?
So Zhijian, I just left some comments on the PR, so you can follow up offline. That's fine.
Okay, thanks.
Okay, if you know other questions, thank you, Zhijian, for the midnight presentation. By the way, team, I will cancel next week meeting. So next week is one summit, and also there is no topic. So I will cancel next week. See you later. Bye-bye.